Good day everyone, you are welcome back to mathematics class. In today's class we are going to be looking at trigonometry. Okay, so let's begin. Now we'll first of all look at trigonometry ratios. That is what we are going to start with today. So permit me to draw a right angle triangle before we proceed. Okay, so this is a right angle triangle. Understood. Okay, so this is a perfect right angle triangle. So now let's continue with this right angle triangle that we have. Let me label this as A. Then this point, let's call it point B, and then the third side here we call it C. Okay, so this side that is facing B, okay, no, well, let me first of all say that this angle B here, this is where our 90-degree lies. You know, a right angled triangle is a 90-degree angle. Okay, so at this angle B is 90-degree. When you see this side, so just know that it's 90 degrees. Understood? So where this angle B is facing, we'll call it side small letter B. Where this angle C is facing, we call it small letter C. And where this angle A is facing, we call it small letter A. Understood? So we are going somewhere, just keep following. Now this angle C here, let's call it theta. Okay, so that is theta. And permit me to call this angle A here, let's call it P. Okay, now as you would have known before, that the longest side of a right angle triangle is what we call hypotenuse. So let me just label this side hypotenuse, the longest side. Okay, then where this triangle is using to sit down is what we call the adjacent. Then where this angle C is facing is what we call opposite. So this is so because we want to first of all consider this angle theta. Okay, so when we are considering this angle B, so where this angle P is facing will become our opposite. So take note of that, it's very important. So the angle we are considering, we are going to first of all look at where is it facing. So that side that is facing will be our opposite. Then the remaining two angles is going to go for the opposite, the adjacent and the hypotenuse. Now, from this triangle that you are seeing on the screen, okay, from the triangle ABC, now we want to find what is sine theta. Okay, now before I go ahead and find what sine theta is with you, I want you to remember this short formula that we call SOH CAH TOA. SOH CAH TOA. Okay, so you might have heard about this before. So this is a short formula to know the formula for three trigonometry ratio, which are sine theta. Okay, this one is standing for sine theta, and then this one is standing for cosine, okay, which is shortened as cos, and this one is standing for tan, okay, tangent, and is represented with tan. Understood? So these two other letters in front of each of them is the ratio of the identity. Okay, for example, sine theta will be equal to opposite over hypotenuse. As simple as that. Okay, so I will write opposite divided by hypotenuse. Okay, but now from this triangle that you are seeing on the screen, what will my opposite be, or what is my opposite? Considering this theta, don't forget we are considering this angle theta. So where this angle theta is facing is our opposite. Understood? So the opposite is C divided by the hypotenuse is the longest side, which is equal to B. Understood? Okay, so let's go ahead and find cos theta. Cos theta. Okay, so cos theta from this SOH CAH TOA that I gave you is the formula is adjacent over hypotenuse. So I will write adjacent divided by the hypotenuse. And what is the formula for that? From the figure on the screen, our adjacent is A and then the hypotenuse is B. Okay, so let's quickly look at tan theta. So tan theta is a TOA, opposite over adjacent. Opposite divided by the adjacent. So from the diagram, our opposite is C divided by A, the adjacent. Okay, so let's keep that. Now I want us to also take another angle, the second angle, angle P. Okay, so we are going to find sine P, cos P, tan P like we did for the tan as well. So we are going somewhere, just keep following. So sine P will be equal to sine formula is opposite over hypotenuse. That does not change. Okay, now for this sine P, this angle here, okay, sine P, where is it facing? Is facing the adjacent here. Okay, so this A, this line that is facing this side, is the opposite in this case. Now don't forget. Okay, perhaps let me quickly remove this. Let me remove all these opposites, hypotenuse and the adjacent that I wrote, so that we will not be confused with what I'm saying. Now we are considering this angle P. So where this angle P is facing will be our opposite. Okay, so this other side now will be the adjacent and this will be the hypotenuse. Understood? Considering angle P only, please don't mess it up. Now in this case, our sine P will be equal to opposite, which is now A divided by the hypotenuse, which still remain as B. Then cos P will be equal to adjacent over hypotenuse. So, and our adjacent is C, okay, divided by B. Okay, finally we also have tan P. And P is opposite divided by the adjacent. So what is the opposite for angle P? The opposite is A divided by the adjacent, which is C. Understood? So you have to take note of that. It's very, very important. Okay, so let me quickly take this off again. Okay, so now let's continue. Now, the next thing we are going to do is to do a bit of a comparison between this sine theta, cos theta, tan theta, and the sine P, cos P, and tan P. But before that, I would like you to come back to this diagram. Okay, so this angle here we said is 90 degrees. And then we already know that the sum of angle in a triangle is 180 degrees. Okay, if this place is 90 degrees, then these other two angles, P and Q, will be 45 degree each. Understood? So when you add 45 plus 90 degrees together, it will give you 180 degrees. Now, where am I going to? I want to find the value of this P. So I don't want it to just be letter P. Okay, so for me to do that, if I want to get this angle P, you will agree with me that angle P is equal to 90 degrees minus theta. Okay, minus theta. Because if I take away this theta from this 90 degree, it will give me the angle here. This is what I meant. If this place is 90 and this place is 45, and I want to find this angle P, what will I do? Just say 90 minus 45. So 90 minus 45 will give me 45. Okay, now add all the three angles together. We have 45 plus 45 is 90. 90 plus 90 is 180, which is equal to the sum of angle in a triangle. So understood. Let's quickly continue. Let's continue. So now we have said that our P now, okay, so our P will be equal to uh, 90 degrees minus theta. So take note of this, is very, very important. Now let's go back to all this trigonometric ratio we wrote here. You will discover that cos theta is the same thing as sine p. Okay, see cos theta here. This is it. Now see sine p here. Okay, so you can see that both of them is a over b, a over b. Understood? So that is what I have just bring out here. Now in this case, we can now continue and say, oh, cos theta is equal to sine p. But what is our p? We have said that our p is equal to 90 degrees minus theta. Close the bracket. Okay, so and this is the first formula we are going to be keeping for future use at this point. Take note of this. Cos theta is equal to sine 90 degree minus theta. Okay, if you go back to all these our trigonometric ratios, you will also notice that sine theta is equal to cos p. Let me trace that with you. You see this sine theta, c over b, is equal to cos p, which is also what, c over b. Understood? So you can just say sine theta is equal to cos p, and our p, like we have said, is 90 degrees minus theta. And this is the second formula also we need to take note. Understood? So these two formulas are very, very important for us in the next examples we are going to be looking at now. Understood? Take note of this formula. Now let's continue to the next page. Now we want to take some examples under trigonometry, most essentially the two formulas we proved earlier on. The question says solve the following equations. So we are going to be picking them one after the other. Now let's begin. So the first question we are solving says cos alpha equal to sine 40 degrees. Solution. So if you want to use those formulas that we derived earlier on to solve this question, now since this question is starting with cos alpha equal to sine 40, so out of those two formulas, we are going to be making use of the one that started with cos theta, since our question is starting with cos alpha. Is that taken? Okay, so I'm going to say but cos alpha is equal to sine 90 degrees minus alpha. Close the bracket. So this is the formula we derived the other time, if you remember. So the only thing I did here is to change the theta to alpha in order to suit this question given to me. Okay. Now, since cos alpha is equal to sine, open bracket, 90 degrees minus alpha, so I'm going to replace this cos alpha with this. Okay, that's how to solve this type of question. So I'm going to say sine, open bracket, 90 degree minus alpha, close the bracket, is equal to sine 40 degrees. So if this sine take care of each other, then we are left with 90 degrees minus alpha equal to 40 degrees. Well, if you collect the like terms, you have 90 degrees minus 40 degrees equal to alpha. So 90 minus 40 will give us 50 degrees equal to alpha. So you can now conclude and say therefore alpha is equal to 50 degrees. So this is how to solve this type of question. As simple as that. Well, let's take a look at this second one. The question says sine beta is equal to cos 80 degrees. Solution. Now, let me write the question first. Sine beta is equal to cos 80 degrees. So you will recall that sine theta, but now I will not use theta, I will use what they gave me in this question, beta. Sine beta is equal to cos open bracket 90 degrees minus beta. Okay, so that's the formula we are going to be using. Okay, and then since sine beta is equal to all of this, then I will replace it with the one they gave us inside the question. Then it becomes cos 90 degree minus beta, okay, equal to cos 80 degree. So we have eliminated sine beta that way. So when this cos take care of each other, we have 90 degrees minus beta equal to 80 degrees. So when you collect the like terms, you have 90 degrees minus 80 degrees equal to beta. Then 90 degrees minus 80 degrees will give us 10 degrees equal to beta. Then therefore beta is equal to 10 degrees. Alright, so let's continue to the next question. So the third one says solution. Third one says that sine 2 theta is equal to cos 3 theta. So sine 2 theta is equal to cos 3 theta. Now we are still going to use the formula that begins with sine theta. But what you have to take note here is that this sine now is not just sine theta, it's sine 2 theta. So I'm going to modify that formula as well by including 2 in it. So what do I mean? I will say but sine 2 theta will be equal to cos open bracket 90 degrees minus 2 theta. Instead of just theta, I will include 2 theta. So that's just the only thing we have to do there. Now since sine 2 theta is equal to this, so let's substitute. So we now have cos open bracket 90 degrees minus 2 theta, then equal to cos 3 theta. Then when cos cancel each other, we have 90 degree minus 2 theta equal to 3 theta. So let's collect the like terms. We have 90 degrees equal to 3 theta plus 2 theta. Okay, so 90 degrees equal to 3 theta plus 2 theta will give us 5 theta. So dividing both sides by 5, dividing both sides by 5 will give us theta to be equal to 90 divided by 5 will give us 18 degrees. Okay, so let's continue and solve this. Solution. So sine gamma is equal to cos open bracket gamma plus 20 degrees. So but you should remember that sine gamma is given as cos open bracket 90 degrees minus gamma. Okay, so substitute that, we have cos open bracket 90 degrees minus gamma, then equal to cos open bracket gamma plus 20 degrees. So this cancel out, so we are left with 90 degrees minus gamma equal to gamma plus 20 degrees. So collect the like terms, we have 90 degrees minus 20 degrees equal to gamma, then plus gamma. When this gamma go to the other side, it becomes plus. So 90 minus 20 will give us 70 degrees equal to gamma plus gamma will give us 2 gamma. So dividing both sides by 2, we are left with gamma equal to 70 divided by 2 will give us 35 degrees. Understood. So now let's go ahead. The next question is sine phi minus cos phi equals 0. Solution. So this one now, I will just first of all rearrange so that we have sine phi. I will take this minus cos phi to the other side so that it becomes cos phi. Okay, so but you recall that sine phi, according to the formula we proved the other time, is equal to cos open bracket 90 degrees minus phi. Okay, so therefore we now have cos 90 degree minus phi equal to cos phi. Okay, so this cos cancel cos, so we are now left with 90 degrees minus phi, then equal to phi. Now let's collect the like terms. We have 90 degrees equal to phi, then plus phi. Now 90 degrees is equal to 5 plus 5 will give us 2 phi. Alright, so dividing both sides by 2. When you divide both sides by 2, you have your phi to be equal to 90 divided by 2 will give you 45 degrees. Understood? Let's take the last question, solution. So the question says cos delta equal to sine open bracket delta minus 10. So let's write the question first, then we'll solve. Okay, so you will remember that cos delta is equal to sine open bracket delta, 90 degrees minus delta. Okay, so we are going to replace this in the question given to us so that we have sine open bracket 90 degrees minus delta, then equal to sine open bracket delta minus 10 degrees. Okay, this sine cancel out, then we have 90 degrees minus delta equal to delta minus 10 degrees. Okay, so now collect the like terms. We have 90 degrees plus 10 equal to delta plus delta. So 90 plus 10 will give us 100 degrees equal to 2 delta. So dividing both sides by 2, we are left with delta equal to 100 divided by 2 will give us 50 degrees. So this is how to go about solving this type of question anytime you come across them. So thank you for watching. Bye.